Okay boys, so today we're learning mostly what we need trigonometry for. So we are going to be finding a side that we need in a right angled triangle. So when you're looking for an unknown side, something that you're trying to find for a side, if you're given two sides, then you've got to use Pythagoras' theorem. So Pythagoras' theorem works with the three sides of the triangle. So you're given two sides, you're finding the third side, you use Pythagoras' theorem. However, if you're given one side in a right angled triangle and one angle, that's when you use the trig ratios. So sine theta equals O over H, cos theta equals A over H, and tan theta equals O over A. You use whichever one applies to the diagram you're looking at. So remember that the theta is an angle. Really important that you understand that this is always an angle. That's why they use theta, so that you understand that we only use theta when we're looking at angles. Okay, so coming over here to some examples. So in these questions it says find the value of the variable. Now the variable is the letter. Correct to 2 decimal places. So in this first triangle, the stuff that was given to you in black is there. What I've done in red is labelled the sides that they've given us. Okay, so this side's been given to you, and that's the hypotenuse of the triangle because it's opposite the right angle. So I'm going to write H there. Now this one hasn't been given to you, but that's the one they want you to find. So we're going to label that one as well. And compared to this angle that they gave you, it's not the opposite side because that would be that one, it's the adjacent side. So we're going to label that with an A. So you're only ever going to be writing in red two things. One on the number that you've got and one on the one you're trying to find. If there's nothing there at all and you're not trying to find it, you don't write anything there. Okay, so once you establish the two letters, we've got A and H. That then tells you, if you look back here at these ones, the A and the H belonged with cos. So we're going to use cos theta equals A over H, and I want the rule or the formula written down each time you do it. Then we're going to substitute into that formula. So our angle goes in here, 75 degrees. The adjacent side is y, that goes on the top. And the hypotenuse is 25.3, that goes on the bottom. After you've done that, all you're doing is solving an equation. So we need to get that y by itself on the right-hand side. That means we have to get rid of the divided by 25.3. So we're going to do the opposite of that on the other side, which is times by 25.3. Now, we do write it in front. Normally we would write the times 25.3 at the end. Just the way the calculator works, it's much better if you just write that at the front. And then we're going to put that in the calculator. Now, looking at your calculator. So when you look at your calculator, you need to find where your sine, cos and tan keys are. Okay, so if you have a look at your calculator, here in the middle row, you have sine, cos and tan. Alright, so they're the keys we're going to be using. So to do this question here, we're doing 25.3 times cos 75. So we press in 25.3, sorry, I'll do it again, 25.3 times, and then we want to press cos 75. So up here we're going to press cos, then the 75. Now I know it's got a bracket there, you don't need to close the bracket off to get this right, so just press equals, and that's the answer we've got. After that we're rounding it off to 2 decimal places, so it's 6.55, and we're in centimetres here, so centimetres. The other one over here, looking at B, this one in this triangle, they've given you 31.5. Now that is, sorry, I've written the wrong thing down here, haven't I? So let's change this. All of this will be wrong. Let's start again. Okay, so the 31.3 is actually the adjacent side. The side we're trying to find is opposite that angle. So if we're using O and A, we are using tan. So we're going to write the formula down first. Tan theta equals O over A. Then we're going to substitute everything in. So remember, this is your angle. So it's tan 55 degrees equals, opposite side is E over adjacent side 31.5. We're going to solve an equation. So we're going to get rid of the divided by 31.5, keep the E here. So we're going to do 31.5 times tan 55. And we're going to be putting that in the calculator and rounding it off in a minute. So when we go to the calculator, we've got 31.5 times tan 55. So the tan key is in that same row, the tan's over here. So press tan 55. As I said before, you don't have to close that bracket off, just press equals. And that's our answer. I'll write that on the board. And we're going to 2 decimal places, so we're rounding off. And if you have a look at this one, we're rounding off to 2 decimal places. That's 5 or more, so this is going up by 1. So our answer is 44.99, and it's metres for this question. Okay, looking at C. So this time, we've got the hypotenuse opposite the right angle. We've also got the opposite side. So this time, with the opposite side and the hypotenuse, we're using sine. So we're going to write that formula down. Sine theta equals O over H. Now I'm going to substitute in sine 72 degrees for your angle equals D for the opposite side over 17 for the hypotenuse. Get rid of the divided by 17, bring it over here and times by it. Put it in your calculator, you should know how to do that now. Get your answer and round to 2 decimal places. Okay, coming up to the next one. Now this one looks a bit different because of our angle. When we get to that part, I'll show you what to do with the calculator. So same thing, label your sides. This is opposite the angle, this is your adjacent side. So opposite and adjacent, we are using tan. So we write the formula down, tan theta equals O over A, substitute in. Now this says tan, the angle says 45 degrees, 18 minutes, just like the minutes in time. So 45 degrees, 18 minutes equals, the opposite side is N. That NM just means N metres, so don't worry about that second letter, it's N, over the adjacent side 7.3. So then we're going to do what we were doing before, get rid of the divided by 7.3, come over here and times by it. Now, putting that in your calculator. So, start off the same way at 7.3 times, and then we want to do tan. So we know where the tan key is now, it's over here. So we're going to press the tan button. Now, we want to put in 45 degrees, 18 minutes. So we're going to put 45, and then we're going to press what we've all been calling the bubble key here. Then we're going to press 18. And then we're going to press the bubble key again. And that is actually 45 degrees, 18 minutes. Okay. Press equals. And we get our answer. There it is there. And then we're rounding it off to 2 decimal places, which you should know by now how to do that, 7.38 metres. Okay, the last one. Now this one is starting to give you some diagrams. We're going into more real life questions in the next video. But this one, they've already half drawn it for you. So we have an observer standing here, a person. The building itself is here. They've told you the height of the building is 155 metres, so it's very tall. And we have an angle between the building and this line of sight here of 77 degrees. Now the question says, find the distance from the observer to the base of the building. So here's the observer, here's the building, but the base of the building is the bottom of the building. The base is the bottom. So we want to find the distance between the observer and that point there, and I'm going to call it D for distance. You can call it X, you can call it whatever you like. Then we're going to label our sides. This one here, according to that angle, is the opposite side. This one over here is the adjacent side. So again, tan theta equals O over A. We're using tan for it. Tan theta equals opposite over adjacent. So substituting in, we have tan of the angle, 77 degrees. Opposite side is D. Adjacent side is 155. Now we're solving our equation. Get rid of the divided by 155. Come over to the other side and times by it, and use your calculator to finish off. Now this question did not ask for any rounding, so I want you to leave your whole answer as it is. No rounding at all. In the HSC there are a lot of boys and girls that lose marks because they've rounded things too much, too early. It's much safer, and they actually use the HSC marker notes. It's better to leave it as it is, okay? Even with the rounding questions back here, if you make a mistake in the rounding and then you've got that answer written there, often they don't mark the rounding and that answer will be marked as correct even if you make a mistake here. So always write the whole answer down before you do your rounding. We're coming back in the next video to do some more questions.